Okay, so the topic is overriding rules explanation. You can see there are 4 rules for overriding. First rule is arguments must be same, otherwise it becomes overloading. Second rule is return type of overriding can be covariant. Third is overriding method must have same or more accessibility as compared to overridden method. And the fourth rule is about overriding and check exception rule. Okay, so let's discuss all these rules. First, arguments must be same, otherwise it becomes overloading. So what does that mean? Suppose we have class base, and in that we have void display. Class sub extends base, and here we are overriding. So we have a method in child class which has got same name and argument as parent class method. So this is the case of overriding. And as you know, this base class method or parent class method is always called as overridden method, and child class method is called as overriding method. You shouldn't call them as parent class method and child class method. You should call them as overridden method and overriding method. So this is the case of overriding. This is the first rule. Argument must be same. Okay, you can see here argument of overridden and overriding are same. If you give different arguments, so what will happen? Will you get error? No. Suppose here, if I write int k, now this is no more overriding. It becomes overloading now. This is overloading. How come? Now you can say that subclass has got 2 methods. Display int its own method and display without argument, which comes from base class. So this is overloading. In Java, overloading can happen in same class as well as different class. But different class, I mean parent and child class. For example, if I write class sample, and in that if I write void fun and void fun string s. Now what is this? This is overloading. Method name same but different arguments. So this is overloading in same class, and here this is overloading in different classes. Okay, base class has got void display and subclass has got void display int k. So while overriding a method, suppose by mistake you change the argument, you don't get error, but it will not be considered as overriding. It will be considered as overloading. So this is overloading. In overriding, argument must be same. So that is the first rule. Okay. Let's go to second rule. The second rule says return type of overriding can be covariant. Return type of overriding can be covariant. So let's see what is covariant. This is your, I will change the argument. So this is the case of overriding. This is, what do you call this method as? Overridden method. And what do you call this method as? Overriding method. Okay. Okay. Now this rule, overriding method can have covariant return time. What does that mean? Suppose overridden method's return type is object. You know, object is the parent class of all the classes in Java. Now here, if I have object as a return type of overriding method also, then this is the case of same return type. That is allowed. In fact, that is allowed from the very first version of Java. Covariant rule came in Java 5, 1.1.5. So if I give same return type here, object, it becomes similar return type. But what do you mean by covariant return type? Covariant return type means instead of object, I can have any child of object. I can have any child of object. For example, string. Now this is the case of covariant return type. Now this is covariant return type, you can say. Why? Because overridden's return type is parent and overriding's return type is child. Instead of string, you can have any class because every class in Java is derived from object class. Okay, so this is covariant return type. Now we need to understand how this covariant rule works. Or suppose if I write here string and here object. Is that correct? No, it's wrong. It's wrong. This is not a covariant return type. You will get compulsion error. So how covariant return type works and why this thing is not allowed? Here string and here object. Why it is not allowed? Let us discuss that. So let me start with this here object and here object, the same return type. So somewhere in the code, public class demo and your main function. Now here suppose if I write base ref is equal to new sub. Base ref is equal to new sub. And here if I say object O is equal to ref dot display. Now first of all, what compiler will do here? For compiler, ref is of base type. For compiler, ref is of base type. So compiler will search display in base. Is it there? Yes. Is it accessible? Yes. What is the return type of object? Sorry, what is the return type of display? The return type of display is object. So have you written object on the left hand side? Yes. So that is perfect. Huh? Since the return type of display is object of base class and you have written object, that means compiler has no issues. Now further, compiler will check, is display final? No. Is it static? No. So compiler goes for late binding. And as per late binding, what is the concept? Content of ref will be searched and display will be called accordingly. So what is the content of ref? Content of ref is sub. So when sub method is called, when subclass method is called, and if it gives object, when subclass method is called, and if it gives object, are we ready? Yes, we are ready. We are ready with the object. I repeat, during runtime, the content of ref would be sub. So subclass display will be called. If that subclass display gives us object value, are we ready on the left hand side? Yes, we are ready. So that's how it works. Now here, suppose if I go for covariant return type, in this case, covariant. So this is the covariant return type allowed by compiler, allowed by Java 5. So let's see how does it work. Now overridden's return type is object and overriding's return type is string. Again, here, as per compiler, this will be late binding. Why? Because display is neither final nor static. So as per compiler, this is late binding. So as per late binding, which method will be called? What will be the content of ref? Content of ref will be sub. So subclass display will be called. And if that subclass display gives string, are we ready? Can we collect string inside object? Yes, we can collect string inside object. We can collect child inside parent. So that's how this rule works. Covariant return time. I repeat, during runtime, content of ref will be display. Sorry, content of ref will be sub. So subclass display will be called. If subclass display gives string, are we ready? Yes, we are ready with the object. Object can collect string. Now, let us discuss. If I do vice versa, here string and here object. Will that work? No, it won't work. Compiler will give you error because this is not a covariant return type. Okay, but why it doesn't work? Why compiler does not allow this? In order to understand that, let us assume, let's say for the time being, let us assume that this is allowed by compiler. I repeat, we assume that it is allowed by compiler. So now we need to think what can be the side effect of it. What can be the side effect of this code? If this thing is allowed by compiler, what can be the side effect of this? Okay, now check everything right from the beginning. For compiler, ref is of base. Compiler will search display in base. Is it there? Yes. Accessible? Yes. What is the return type of base class display? What is the return type of base class display? A string, right? And what have you returned? Object. But here if I write string, just think, is it okay for compiler? If I write here string, is it okay for compiler? Yes, because ref is of base type. Compiler will search ref. Compiler will search display in base. Compiler will search display in base. Is it there? Accessible? What is the return type of base class display? String. So are you collecting in a string? Yes. So that's okay for compiler. Compiler does not have any objection. I repeat, for compiler, ref is of type base. Compiler will search display in base. Display of base has got return type string, and since you return string, that is perfectly okay for compiler. Now, since display is neither static nor final, compiler will go for late binding. And as per late binding, what will be the content of ref? Content of ref will be sub. So during runtime, subclass method will be called. And subclass method, if subclass method gives you object, are we ready? If subclass method gives object, are we ready? No, we are not ready. Because if subclass method gives object, we are trying to collect in a string. So that will fail during runtime. Child cannot collect parent. Parent can collect child, but child cannot collect parent. Okay. So during runtime, subclass display will be called. If that gives object, we are not ready, our code will fail. That should not happen. That should not happen during runtime. That's why compiler will stop you here itself. This will be the error. Okay. So since we have this side effect for the code, compiler will not let it happen. Compiler will save your code from runtime blunder. How? Compiler will give you error over here. So this will not compile. Okay, so that's how this second rule, return type of overriding can be covariant, makes sense. Now we'll move to third rule, which is the accessibility rule. It says that overriding method must have same or more accessibility as compared to overridden method. It says that overriding method must have same or more accessibility as compared to overridden method. Let's do it. Now, in order to understand this rule, same or more accessibility, you must understand which is the lowest accessibility and which is the highest accessibility. So, as we know, there are 4 accessibility modifiers. First is private. This is the lowest. Why? Because private is accessible only in the same class. Above private, we have default. Default is not a keyword for accessibility. Above private, we have default. Why? Because default is accessible everywhere in the same package. Default is accessible everywhere in the same package. Default is not accessible outside the package. Then we have protected. Protected is more than default. Why? Because protected can be accessible outside the package, provided the class has to be the child class. And above protected, we have public, which is accessible everywhere. So this you must know in order to understand this third rule of overriding. Okay, let's start. Now suppose we have this code, class base void display, class sub extends base void display. This is overridden method and this is overriding method. Now which accessibility we have here? Overridden has got default and overriding has got default. And what does rule say? What does rule say? Rule says that overriding method must have same or more accessibility as compared to overridden method. So this is same, isn't it? So this is correct. This is correct. Now let's see how does it work. Suppose I have got this code, class base void display, class sub extends base void display, and somewhere in demo class I have written this statement, base ref is equal to new sub ref dot display. Now just discuss. For compiler, ref is of type base. For compiler, ref is of type base. Compiler will search display in base. Is it there? Yes. Is it accessible? Can default be accessible from main in the same package? Yes. Why not? Is it static? No. Is it final? No. So compiler goes for late binding. Compiler goes for late binding. So as per late binding, what will be the content of ref? The content of ref will be sub. So subclass method will be called. Now think. Is it okay to call subclass method from main? Yeah, there's no problem because subclass display is default and you are accessing it within a package. Subclass display is default accessibility and you are accessing that display within a same package. So there's no harm, no side effects. So that's how this code, this rule works. So instead of default, what all other accessibility modifiers we can have? Can we have protected? Yes. Can we have public? Yes. Okay. But can we have private? Now protected, public and default comes under the rule because rule says that overriding method must have same or more accessibility. If this is default, it can be default, it can be protected, it can be public. Why? Because protected and public are more than default. But can I write private here? Can I write private here? No, it will not compile. Why? Because you have given weaker access privilege, weaker accessibility. Private is weaker than default, isn't it? Private is weaker than default. So this is not allowed by compiler. Compiler will give you error. But let us think why this is not allowed by compiler. What can be the side effect of it? What can be the side effect of it if this is allowed? Let us think. And in order to understand that side effect, let us assume for the time being that this is allowed by compiler. This is allowed by compiler. Okay, now think what will happen here. Base ref is equal to new sub ref.display. For compiler, ref is of type base. Compiler will search display in base. Is it there? Yes. Is it accessible? Yes, default can be accessible within the same package. Is it static? No. Is it final? No. So compiler goes for late binding. Compiler goes for late binding. And as per late binding, what is the content of sub? What is the content of ref? Content of ref will be sub. So subclass method will be called, isn't it? Now think, look at the subclass. If subclass method gets called, what will happen? If subclass method gets called, it will violate the accessibility rule, the rule of private. Correct? It will violate accessibility rule. It will violate the rule of private. That should not happen. That should not happen because private will be called from other class. That should not happen. That's why compiler will stop you here. So this will be the error. Compilation error. Okay, so this is our third rule, accessibility. I hope it is clear to you why this is not allowed. What can be the side effect of this? Now let's go and discuss this fourth rule. Fourth rule is all about overriding and checked exception rule. Remember, checked exception and not unchecked exception. In the fourth rule, we have three subpoints, A, B, C. That is, overriding method may not declare any checked exception. Overriding method can declare same checked exception or is subtype declared by overridden method. And overriding method cannot declare checked exceptions not declared by overridden method. So let us discuss one by one. I will first take this. Overriding method may not declare any checked exception. So since accessibility is over, I will remove that private. Okay. So first point. Overriding method may not declare any checked exception. What does that mean? You know how to declare exception. Which keyword is used? Throws. So suppose here we have IO exception. Here we have IO exception. And here we haven't declared any exception. Overridden method has declared IO exception, which is a checked exception, and overriding method has not declared any checked exception. So that is perfectly right. Overriding method may not declare any checked exception. Now let's discuss how does it work. Let's discuss how does it work. Overriding method may not declare any checked exception. Somewhere in the main function, I have written this code: base ref is equal to new sum, ref.display. Now what do you think? Will this code compile? Especially ref.display. Will it compile? What do you think? Will ref.display compile? No. Remember handle or declare rule. Ref.display will not compile because we are calling, see, for compiler, ref is of base type, right? For compiler, ref is of base type. So compiler will search display in base. Is it there? Yes. Accessible? Yes. But that display has declared checked exception. So as per handle or declare rule, whenever you are calling a method which has declared checked exception, either you have to handle it or declare it. Either you have to handle it or declare it. Main is neither handling nor declaring. So this will be compilation error. So how will we correct that? We'll correct that with try catch. Which catch? IO exception. At least IO exception, right? At least IO exception has to be there. IE. Then I will write IE dot print stack trace. Okay. Now it will compile. Why? Because we are trying to call a method which has declared checked exception and we are handling it. Okay, so this will compile successfully. Now, since the method is neither static nor final, compiler will go for late binding. And the late binding content of ref would be what? Content of ref would be sub. Now think, when subclass method calls, when subclass method gets called, it is not giving you any exception. It's not giving any exception and you are still ready with the try and catch. Is it a side effect? No, it's not a side effect. The method is not giving you any exception. The method is not going to give you any exception and you are still ready with the try and catch. So there is no problem. And that's how this rule makes sense. Overriding method may not declare any check exception. Second point. Overriding method can declare, I will write this point here. Second point says, overriding method can declare same check exception or is subtype declared by overridden method. So what I will do, I will just take this much, or we'll see later. Overriding method can declare same check exception. What does that mean? Overridden method has declared IO exception and overriding also will declare IO exception. Suppose overriding also declares IO exception, then it is perfectly right for compiler. Now let's see how this rule makes sense, how this point makes sense. So overriding method can declare same check exception. Same. This is IO exception, this is IO exception. Okay. So overriding method is also declaring IO exception. Now think here again, for compiler, ref is of type base. Compiler will search display in base. Is it there? Yes. Accessible? Yes. But it has declared IO exception. So are you handling that? You should either handle or declare. Huh? Are you handling that? Yes, we are handling that. So it will compile successfully. At the same time, since display is neither static nor final, compiler will go for late binding. And as per late binding, which method will be called? Because the content of ref will be sub. So as per late binding, subclass display will be called. Now think, if subclass display gives you IO exception, if subclass display gives you IO exception, are you ready? Yes, you are ready with the try and catch. Huh? I repeat, if subclass method gives you IO exception, are you ready? Yes, we are ready with the IO exception. So that's how this point makes sense. Which point? Overriding method can declare same checked exception. Now that OR part. OR part. OR is subtype. What does that mean? OR is subtype. It means that if overridden method has declared IO exception, overriding method, let's say, is declaring file not found exception. Now you understand that file not found exception is a child class of IO exception. File not found exception is a child class of IO exception. So this is also allowed. Let's see. How does it make sense? How does this point make sense? Let's see. This is allowed. Huh? Come to the main function again and let's discuss again. For compiler, ref is of type base. Compiler will search display in base. Is it there? Yes, but it is declaring IO exception. So have you written either try catch or throws IO exception? Are you declaring or handling? Yes, we are handling IO exception. So this is perfectly okay for compiler. But since, once again, display is neither static nor final, compiler will go for late binding. And now think, if compiler goes for late binding, the content of ref will be sub. So subclass display will be called. If subclass display gives you file not found, are you ready? If subclass display gives you file not found, are you ready? Yes, we are ready. How come? IO exception can catch file not found exception. IO exception can catch file not found exception. In other words, parent can catch child. Parent can catch child. IO exception can catch file not found exception. Okay, so that's how this point makes sense. Last point, overriding method cannot declare checked exception not declared by overridden method. What does that mean? First of all, overriding method cannot declare check exception not declared by overridden method. Suppose we'll discuss two scenarios for this point. We'll discuss two scenarios for this point. One is, let's say, suppose my overridden method is not declaring any checked exception. My overridden method is not declaring any checked exception. And here I have written, let's say, file not found exception, which is one of the checked exceptions. Now this is not allowed. This is not allowed by compiler. You will get compilation error. Why? Because overriding method is trying to declare the checked exception which is not declared by overridden method. Overriding method is trying to declare the checked exception not declared by overridden method. This is not allowed by compiler. But why it is not allowed by compiler? What can be the side effect of it? What can be the side effect of it? In order to understand side effect, once again, we need to assume, we have to assume that this works at compile time. I repeat, we assume that it works at compile time, and now we'll think what can be the side effect of this code. Now, think about main function code. Think about main function code. Base ref is equal to new sub ref.display. For compiler, ref is of type base. Compiler will search display in base. Is it there? Yes. Is it accessible? Yes. Has it declared any checked exception? No. So we neither need handle nor declare in the main. Moreover, base class method is neither static nor final. So compiler will go for late binding. Now, as per late binding, which method will be called? As per late binding, subclass method will be called. If that gives file not found exception, are you ready? If that gives file not found exception, are you ready? No. Your execution will be aborted. Your execution will be aborted. That should not happen. That's a side effect. That should not happen. That's why compiler will stop you here. So this will be the compilation error. This will be the compilation error. Okay. This is one scenario. One more scenario is, suppose if I have written here file not found exception, and here I have written IO exception. You know, IO exception is a child of file not. IO exception is a child of file not found exception. If I have written this, now think, are we following the rule? The rule says overriding method cannot declare checked exception not declared by overridden method. Here, overriding method declares checked exception, which is a parent of the checked exception declared by overridden method. Overriding method declares checked exception, which is a parent of the checked exception declared by overridden method. This is also not allowed. You will get compilation error. But once again, let us discuss why there is an error. What is the side effect if this thing is allowed? What can be the side effect if this thing is allowed? And for that, we have to assume that compiler allows this. So for the time being, let us assume that this is allowed by compiler. Now tell me, will the code of main compile? Will the code of main compile? No, it will not compile. Why? Because for compiler, ref is of base type. Ref.display. Compiler will search display in base. Is it there? Yes. Accessible? Yes. But it has declared file not found exception. It has declared file not found exception. So at least you should have try and catch. So you will write try and catch in order to solve that error. Catch file not found exception. Right? F.print status. Now will it compile? Yes. Because base class display has declared file not found exception and you have handled it as per handle or declare rule. So compiler is happy with that. Moreover, display is neither static nor final in base. So compiler will go for late binding. Compiler will go for late binding. And as per late binding, which method will be called? As per late binding, subclass method will be called. Now think, if subclass method gives you IO exception, if subclass method gives you IO exception, are you ready? No, you are not ready because you have file not found exception in the catch. File not found exception cannot catch IO exception. File not found exception cannot catch IO exception. Okay, child cannot catch parent. Child cannot catch parent. So it will abort the execution. That should not happen. That should not happen. This is a side effect which should not take place. That's why compiler will stop you here. So this will be your compilation error. Okay. In this point, I would like to add one more thing. Some people will now argue, what if we write here exception? What if we write here exception? Now it should work. Now there is no side effect, because if I write exception here, first of all, as per compiler, ref is of base. Base display has declared file not found exception, and you have written catch exception, which is the parent of all the exceptions. So that is perfectly right for compiler. Since display is neither static nor final, compiler will go for late binding. As per late binding, content of ref will be sub. If subclass method gives IO exception, are we ready? Yes, we are ready, because we have written exception. Exception is the parent of IO exception. So some people will argue that it should work now. They will argue, yes, it will work in your case. But what will happen if I write file not found exception? What will happen if I write file not found exception? So in that case, it will not work. So rules are made in Java after considering all the scenarios, all the possible scenarios. It's not that if you write exception, it should work, or if you write file not found exception, it should not work. It's not like that. Rules are made after considering all possible scenarios. So client may write exception, client may write file not found exception, who knows? So they have considered all possible scenarios, and they came to the conclusion that yes, we are not going to allow this thing. Overriding method cannot declare check exception not declared by overridden method. So that's how this rule makes sense. So in that way, we have finished all the rules of overriding.